Welcome aboard, innovators, to Idea Mechanics. I'm your navigator, and today we're firing up the engines to unlock one of the most powerful tools in the entire TRIZ toolkit. We're going to systematically dismantle problems that seem, well, impossible. Ready to engage? Let's go.
So tell me, have you ever been stuck between a rock and a hard place in a design? You need a part to be incredibly strong, but it also has to be flexible. Or maybe you need a process that's super fast, but it also needs to be incredibly precise. These kinds of contradictions can stop a great idea dead in its tracks.
And the reason we get stuck, well, it's usually because we've walked right into the one-size-fits-all trap. We just get locked into this mindset that one single uniform solution has to solve the entire problem. But here's the thing. What if that very assumption of uniformity is the problem?
Okay, we are going to break out of that trap, and we're going to do it with a much more systematic way of thinking. It's TRIZ Principle number 3, local quality. And believe me, this isn't just another technique on a checklist. It is a fundamental shift in how you see and solve problems.
So what is local quality? Here's the core of it. Stop looking for one perfect material or one perfect condition for the whole system. Instead, you optimize each part for its own specific local job. You're designing for what each little piece actually needs to do.
This question, this right here, is the master key. I want you to burn this into your brain. The second you ask, wait a minute, why does this thing have to be the same all over? Bam! You shatter the old constraints and open up a whole universe of new, elegant solutions.
All right, theory is great, but let's put this principle to the test. Our first case study is a classic manufacturing paradox, that constant battle between strength and durability. Okay, think about a simple steel gear. If you make it out of super hard steel, yeah, it'll resist wear like a champ, but it's brittle. One good shock and it could literally snap. So what about using softer, tougher steel? Well, that can handle the impact no problem, but the gear teeth will wear down to nothing in no time. It's a lose-lose situation, a classic trade-off.
So what's the TRIZ solution? It's not some exotic, super expensive new alloy. No, it's much smarter than that. The solution is to change the structure itself. We're going to move away from a uniform or homogeneous structure, and instead we're going to intentionally create a non-uniform, heterogeneous one.
The technique that makes this happen is called case hardening. Check this out. First, you don't mess with the whole part. You just infuse the outer layer, the surface, with carbon, leaving the core totally alone. Then, you rapidly cool it, you quench it. And because only the surface has that extra carbon, only the surface becomes ultra hard. The inside stays tough.
And there it is, the power of local quality in action. You get the absolute best of both worlds, exactly where you need them. You've got a super hard, wear-resistant exterior for the gear teeth and a tough, shock-absorbing core to handle all the stress. The contradiction? It's gone. Solved. No compromise needed.
Now, this principle isn't just for physical objects. Not at all. It's just as powerful when you apply it to processes and environments. So let's look at another application where we shift from a static system to a much more dynamic one.
Imagine your job is to separate a really complex chemical mixture. The old uniform approach would be to what? Heat the whole tank to one single temperature and hope for the best? That is incredibly inefficient. Why? Because the different things in your mixture all separate best at different temperatures.
So applying the local quality solution means we throw that uniform condition right out the window. Instead, we're going to create a gradient, a smooth, continuous change in a property, like temperature, across the whole system.
A perfect real-world example is an industrial distillation column. This thing doesn't have one temperature, it has a whole range. It is specifically engineered to be hottest way down at the bottom and coolest way up at the top. This creates a perfect temperature gradient all the way up.
So what happens? It's brilliant. As the mixture heats up from the bottom, things start to vaporize. As the vapor rises into the cooler zones, different components condense back into liquid at different heights, all based on their unique boiling points. Each local area, each temperature zone in that column is perfectly optimized to separate out one specific thing. It's an unbelievably efficient and precise system.
Okay, let's process all that data. What's the big takeaway from our deep dive into TRIZ Principle 3? What's the mission summary from us here in Idea Mechanics?
It's this right here. Real, repeatable innovation. It isn't about waiting around for some magical spark of genius. It's a discipline. It's the discipline of looking at something that seems solid and uniform and having the courage to realize it doesn't have to be the same everywhere.
So here's your mission directive.
Stop wasting your time hunting for that one, single, perfect solution that does everything. It probably doesn't exist. Instead, start every single design challenge by asking that game-changing question: why does this have to be uniform? Then, use local quality to build your solution with surgical precision, giving each part exactly what it needs to do its job perfectly.
And I'll leave you with this final challenge. Look around you. I mean, really look. At the products you use every day, the processes at your job, maybe even the routines in your life. What uniform system is just sitting there, waiting for you to apply local quality and unlock a brilliant new solution? Go find out.